I have to cancel the last column. Why should I cancel the last column? Because the last column becomes 0. So I am cancelling the last column. Since I cancelled this column, so there is no need of penalty for that column at all. That's why I have given what here? Hyphen. I am writing the hyphen. Check that I am writing the hyphen here in this. Check it. And now I have to find the penalty again. Penalty again. So first minimum, second minimum. First minimum is 5, second minimum is 10. So difference between these two is what? 5. I am writing these things first because there is no change in this first minimum, second minimum, because when you strike out the column, there is no change in these columns. So I have written 1 2 4 directly. Then I am writing this change. So first minimum, second minimum 5, first minimum, second minimum 3, first minimum, second minimum 1, first minimum, second minimum 6, first minimum, second minimum 2. So after entering all these things, which is greatest in the second penalty? Which is greatest in this second penalty? 6. That's why I have given in some other color. After marking that as a 6 is your uh, largest penalty, in that column should I allocate for a column or a row? Now I should row or a column? Should I see a row or a column now? If it is available here, I watched the column. Here I have row. Among that row, 14, 7 and 11, sorry 1. Which is least in this? 14, 7, 1. Which is 1. So for that I have to give the allocation. How much I am giving the allocation? I am giving the allocation as 20 because 20 here, but how many am I having here? 30 here. So which is least among these two?
20.
20. That is why I am giving the 20 here. And reduce the 20 from this 20, reduce the 20 from this 30, that becomes 10. So now you tell me which I have to cancel. Should I cancel the column or a row? Column. So I'm cancelling the third column. After cancelling the third column, where should I put the hyphen? In the third penalty row, I should put a hyphen here. So I'm having hyphen here. Already I have an hyphen here. So these two things are no need to worry hereafter. I have to find the penalty. Since I'm cancelling the column, there will not be any change in these things. First minimum and the second minimum. That is equal to what? 1. And here also you have first minimum is 5, second minimum is 7. So difference is what? 7. I said the word difference. Don't subtract it. Just find the modulus difference value. So everything in the penalty will be what? Positive. You will not be having a negative penalty. After writing the third penalty for the column, I am writing it for a row. So 20 minus the first minimum, second minimum, the maximum, the difference is 10. First minimum 9 and next minimum is 13, the difference. So after writing all the differences, now you see that which is maximum in this third penalty. In this third penalty, which is maximum?
2.
Maximum
10, sir.
10. I have given it in some other color. So the maximum is 10. So for the 10, should I go for a row allocation or column allocation? Row allocation. So 10, 20, which is minimum? 10, 20. 10. So for the 10, I have to go for a allocation. Why do I put 10 here? Because 60 and 10, which is least in these two? Which is least in these two? 10. So that 10 should be given in that column, in that cell, and reduce the 10 from this 10 from this 60. So now you tell me which row or a column I have to cancel.
Row, sir.
Row. You have to cancel the row. After cancelling the row, this becomes where do you have a hyphen? Means in the first place you will be having a hyphen. I am giving the hyphen here. After giving the hyphen, you need to go for a fourth penalty. I am finding the fourth penalty. So first minimum, second minimum, first minimum, second minimum. You have to identify 4, 1, 7, 9, and likewise you have to go for a finding the. I am giving the hyphens here. No need to worry about those places. And now you have first minimum. என்னாச்சா யார் திடீர்னு என்ன சத்தம் கொடுக்குறாங்க? Those who are attentively listening can unmute your mic whenever I'm asking question. You can respond. Okay. Now first minimum, second minimum. 3, 4, 1, 5, 7. So difference is 2. So now you identify the maximum in this fourth penalty. Which is maximum here? Which is maximum?
9.
9. So for that you have to go for a row wise 3 or 12, which is least. 3 is least. So I'm allocating 50 in this. So 50 here and 50 here. Both of them is getting vanished. So both of them, this 50 becomes 0 and this 50 becomes 0. Now you tell me whether I should cancel row or a column.
Both, sir.
Both. Very good. Someone has been keep on listening. I don't know who is that responding it. Let me.
Nidhi.
Who is it?
Nidhi.
Nidhi. Very good. You are listening carefully. That's the. I need to go back to the place who is responding it. That's why. Okay.
Okay, sir. No problem.
No problem. Okay. Now I have to cancel both the row and the column. That's why you have the left out. Now you see this, just a column alone is available, so we can directly allocate here after. If at all you want to extend the penalties and then do that, it doesn't matter. But see this, you have only one column and few set of supplies are there. You can directly substitute it. If I substitute 20 for 9 and 30 for 5 and 10 for 7, when you add all these things, now we have the allocations. Now we have the allocation. See that 10, 20, 30, 10 plus 20 plus 10 becomes 40, 50. Likewise, if you come in a column wise, 10 plus 50 is 60, 20 plus 30 plus 10 it becomes 60, and 20 is available and 10 is available. So now you can write the allocation transportation matrix by VOGEL'S approximation method. So by the VOGEL'S approximation method, first I am writing the just the cost matrix and then these allocations. After entering these allocations, you can find the number of rows and number of columns. So the number of row equal to 5, number of column equal to 4. You should find the number of allocations is 7. You should find m plus n minus 1. M plus n minus 1 is 8. So but you have only 7 allocations. The condition is not satisfied. So you should find this solution is degenerate 1. In order to resolve the degeneracy, I have to include what? A small quantity epsilon. So I'm going to enter that epsilon for my convenience. For my convenience, if I enter it here, I'll be having a 4 allocations in this fourth row. If I enter here, I'll be having 4 allocations in this. So both of them is comfortable, but when I enter 14 or 12, so 14 is greater, 12 is lesser, so I'm going to put the epsilon in the 12. Nowhere else I can put the epsilon. If you want to put the epsilon anywhere else, it doesn't affect the uh, cost final transportation cost when you turn the epsilon into 0. But why I am insisting this, when you put like this, it will be comfortable for identifying the optimal solution. The problem, actually you have to find the optimum solution. So after entering this epsilon, the initial transportation cost.
Sir, we can put in 14, no, sir.
Okay, who is asking this question?
Same, Nidhi.
Okay, Nidhi, why can't you put that in 14? Means, let me tell again, 14 is a greater cost. Cost rupees 14 is greater.
Greater number.
Greater.
Okay, sir.
It's a cost matrix. The matrix
Okay, sir. Okay, sir.
14 rupees is greater than 12 rupees. That is why I am giving it in 12 rupees epsilon. Another thing you should understand, that I am not giving it in anywhere else, because 20, if I put it epsilon here, that is there also I am having what? 4 allocations. Our intention is to maximize the number of allocations in a single row or a column. If I put epsilon here, number of allocation increases. Can you able to hear me? Can you able to hear me?
Yes, sir. Yes, sir. Yes, sir.
Yes, sir.
Because I come to know that some disturbance. We don't know when I am disconnected. I'm unable to identify whether I'm disconnected or not. That's why. Okay. So what's our problem? Yes, I should explain where I should put the epsilon. So I have a choice of putting epsilon here in the place of 20 rupees, or in the 14 in the rupees 14, or in the place of 12. Among these three places, I choose 12 because it's comfortable for us to find the optimum solution. So the initial transportation cost by Vogel's approximation method is, to find it, still we are reduced it to 670 rupees. Last time we had 760 rupees when you find it with the help of what method means uh, least cost method.
No plus.
But in the matrix minimum or least cost method we get what, 760. But now we got it rupees 670. So now only I'm going to explain you the Modi method, but it seems that we have extending the time. Can you bear another 10 minutes?
Okay, sir.
Okay, okay, okay. To find the optimum solution, this is the method. I'm introduce the method only. We'll solve the problem in the next class. So to find the optimum solution, the number of non-negative allocations at the independent positions is equal to m plus n minus 1. So our condition is satisfied because we substituted epsilon. So m plus n minus 1 on the 8. So we have 1, 2, 3, 4, 5, 6, 7, 8. Our condition is satisfied, therefore we can make use of Modi method. The Modi method, I'm writing without writing the supply and demand, I'm just writing the cost alone in this. That too, I'm writing the cost in the topmost position. Since I can't able to write this one in the tabular column in the top, the 10 should be written in the top left corner. After writing the top left corner, that cost L, and then I'm writing what, allocations. After writing the allocations along with the epsilon I have written the allocations. Now this Modi method is also said as UV method. Y means we use U's and then V's. So why do we tell this as a UV method? Because of we need to find the values of ui's and then ui's and then vj's. That's why we say that the Modi method is also named as what, UV method. Why I use that 0 here anonymously? I'm writing this as 0 because you have to identify the maximum allocated row or a column. How many allocations we have in this row? First row. How many allocations in the first row? Hereafter you need to answer it quickly so that I can able to tell it.
1, sir.
How many allocations in the second row?
1, sir.
In the third row?
1.
1, sir.
Okay. Fourth row?
3,
sir.
Okay. First column?
2.
Second column?
3.
Second column along with epsilon. Epsilon is also allocated. So how many allocations? 4 allocations. In the okay. In the third row? Sorry, in the third column, in the third column
1, sir.
Okay. It is instructed that someone is keep on disturbing. Let them not to do it. Fourth column, we have only 1.
1, sir.
Okay. So maximum, where do we have the maximum allocations? We have the maximum allocation in the column, in the second column. So anonymously we are taking the second column u2 values, sorry, v2 value as what, 0. v2 value as 0. After identifying that v2 value is 0, we are going to make use of a formula. The formula is what I have written here: c suffix ij equal to ui plus vj. C suffix ij. What is c suffix ij? The top corner value. That is cost. C is meant for cost, and u are all for these u's, and then v are all for these v. So the formula I am going to find, I have given that the value 0. Using the value of 0, I can able to find the values of the rest of the values of entire u1, u2, u3, u4, u5 v1 v2 is already available, v3 v4. How do I find with the single element? Using the v2 I'm going to find the rest of all the elements, unknown elements. How I'm finding it? With the help of this formula. See that what is the position value of this allocated cell? It's a cell value 2 comma 2, because the cell value 1 comma 1, 1 comma 2, 1 comma 3, 1 comma 4, 2 comma 1, 2 comma 2. So this 2 comma 2, that is what I am written, cell value 2 comma 2. Cell value 2 comma 2 is nothing but what? u2 plus v2. You know the value of v2. What is v2?
0.
0. Substitute that 0 here, and the value of c22. Value of c22 cost. What is the cost for this cell is? What is the cost?
20.
No, cost. 20 is allocated.
9.
9. The cost for this is nothing but what? 9. So I am substituting that 9 here, and you got the value u2 equal to what?
12.
No,
9, 9,
9.
9.
Okay,
9.
u2 equal
Sorry.
to 9. Okay, doesn't matter.
9.
So u2 equal to 9. In similar way, you have to look up for the allocated cell. When I go for a next allocated cell, what is allocated cell value here? Cell position of the cell is 3 comma 2. So that's what I'm going to find, 3 comma 2. When I find that 5, and as usual you'll be having 0, that's why you have u3 is also what? 5. And similarly u4 equal to 7, and u5 equal to 12, because when you have zeros, so I am able to find the value of, that is why you have, similarly I am finding u3, u4, u5. After entering the value of u2, u3, u4, u5, you have to look for the allocated cell. So when I go for allocated cell, I am finding that 4 comma 3. What is 4 comma 3 cell value? 4 comma 3, because you have 7 here. 4 comma 3 is
9, sir.
4 comma 3, fourth
7.
fourth row, fourth
1,
column,
sir.
1. So 4 comma 3 is 1, and the u4 is 7. I am substituting u4 is 7, and u3 I have to find. Take this 7 to the other side, you get minus 6. So I have to enter v3 equal to minus 6. I'm finding v3 equal to minus 6. Similarly, cell number 4 4. Why do I find that? Means because you have one allocated, one value we have found. Using that found out value, you have to look for a allocated cell. Allocated cell C44 is available. So allocated cell C44, allocated cell C44 equal to U4 plus V4. U4 value 7. V4 we do not keep that V4 as it is. But cost is what here? 0. Substitute that cost here. You will be having V4 equal to, take the 7 to the other side, you get what? Minus 7. So you have V4 equal to minus 7. So substitute that minus 7 here. Put that minus 7 here. Find the next value 511, because we have the value 12 is already available here. I am looking for the allocated cell, because I have to find V1. How can I find V1? With the help of V5, because it is allocated here. So now I can write C51 is equal to U5 plus V1. V1 we don't know, keep the V1 as it is, but V5 you know the value, put the 12 here, and the C51 is 3. I am putting that 3 here. Take the 12 to the other side, you will be getting minus 9. So you have to find the V1. Only one thing we have to find, V1. I can find V1 with the help of this allocated cell with this 9. So C11, the position of this is what? C11. So U1 plus V1. U1 we don't know, keep it as U1 itself. V1 we know it as minus 9. So put that minus 9 here. So take this minus 9 to the other side, you get U1 equal to 19. So we have identified the values of V1 and U1 systematically with the help of the formula C suffix ij equal to U suffix I plus V suffix j to find Ui plus Vj. So every cell we have to identify plus ui plus vj. I have given all these things in red color. See, I'm writing that in top left right corner each and every cell. See that how I'm writing this on the
Okay, sir.
top of the every cell. In the non allocated cells alone, we don't bother about the allocated cell. We don't bother about the allocated cell. In the non allocated cells alone we'll be writing it. So 0 plus 19, I'm writing it as 19. Minus 6 plus 19, I'm getting it as 13. Minus 7 plus 19, I'm getting it as 12. Like that every place. Minus 7 plus 9, I have 12. Minus 7. Minus 7 plus 9, you get 2. Can you able to identify how I'm writing all these numbers in red color? You can just check with any number. Minus 9 plus 5, that is minus 4. These red numbers are all available only in non-allocated cell, because the numbers which is in blue color cell will not contain the number in red color. Can you follow this?
Yes, sir.
Okay. One more thing I have to find. How do I find that ui plus vj? And then you have what d suffix ij is equal to. Subtract these two numbers. 20 minus 19. How much you get? I am writing these things in green color, olive green color.
One, sir.
Yes, 20 minus 9, I get 1. 5 minus 13, I get minus 8. Like that. These are all in olive green color. So d suffix ij are all in olive green color. Do we have negative number in olive green color? Do we have negative number? Negative number in,
Yes, sir. Yes, sir.
so the problem is not optimal. We have to find the optimal solution.
If it is negative, it's not optimal, sir.
Yes. The olive green numbers are, if you have in negative, negative means you have to go for finding the optimal solution. You have to find the optimal solution. So I think I can able to solve this one in the next class. Continuation of the problem will be in the next class. Better we take a new problem and solve the entire problem with the optimal solution. I think I have extended too much of time. Sorry for the inconvenience because of the lack of technical problem. Will